Space analysis in orthodontics. The space analysis in orthodontics regard as a phase of the diagnosis of orthodontic problem to quantify the amount of crowding or spacing in the dental arch or within the dental arch, because the treatment of crowding or spacing varies according to the severity of crowding or severity of the spacing, or according to the severity of the space discrepancy that is determined in the space analysis procedure. The space analysis procedure is done on the study cast, and the study cast either is a physical study cast by analysis of the study model, or virtual study model, which is the space analysis and the measurement are done by the computer. The types of the space analysis is divided into two types: the permanent dentition space analysis and mixed dentition space analysis. In the mixed dentition space analysis there is many types, which includes the MOYER'S space analysis, Tanaka and Johnston space analysis, and space analysis that depend on the radiographs. In the permanent dentition space analysis is either the CAREY'S analysis or Bolton analysis of the permanent dentition. In the procedure of space analysis, we determine the amount of the arch discrepancy, or determine the severity of crowding or the amount of the spacing in the dental arch by comparing between the space available and the space required for the alignment of the teeth in the dental arch. For the space available is the measurement of the arch length, mesial surface of the first permanent molar to the mesial surface of the contralateral first molar, and by a line or brass wire that attach from the mesial surface of the first molar to the mesial surface of the contralateral first molar, and this wire or this line passing through the cusp tip and the incisal edge of the mandibular teeth, and pass through the central fossa and the lingual fossa of the maxillary anterior teeth. This is the space analysis, or the space available, the space available or the arch length in case of the space analysis. The space required is the term that used in cases of mixed dentition, and while in case of the permanent dentition, it's called the total tooth material. And the total tooth material in the permanent dentition measured in the dental arch by measuring the mesiodistal width of each tooth in the dental arch from the first permanent molar mesial surface to the other side of the first permanent molar by measuring each mesiodistal width of each tooth, which include the second premolar, first premolar, permanent canine, the permanent lateral and central incisors for each quadrant, by collecting the total mesiodistal width of all of these teeth to measuring the total tooth material. And this tooth material, total tooth material, is compared with the space available, which measured by the brass wire to calculate the amount of space discrepancy, whether there is a crowding or spacing in the dental arch. The same procedure of measuring of the total tooth material can be done in the computer on the virtual cast by measuring the mesiodistal width at the contact area of each tooth from the mesial surface of the first molar to the mesial surface of the contralateral first molar. That means measuring the mesiodistal width of the second and first premolar with the canine and the lateral and central incisors for each quadrant, and by adding or summation of all of these mesiodistal width of the permanent teeth, we can calculate the total tooth material and compare it with the space available of the arch to measuring the space analysis. And it's this called the CAREY'S analysis of the permanent dentition space analysis, and the CAREY'S analysis by comparing the total tooth material with the space available in case of the mandibular arch. In the maxillary arch, the same calculation of the space analysis, but here it's called the arch perimeter analysis. And by the same method, comparing the space available and the space available, it's represent the arch length from the mesial surface of the maxillary first molar to the mesial surface of the maxillary first molar of the other side, and this is represent the space available and compared with the collective mesiodistal width of the second and first premolar and the canine, and the lateral with the central and the central lateral canine, and first and second premolar on the other side, to to determine the amount of the arch discrepancy, whether there is spacing or crowding, and determine the severity of crowding for the correct treatment plan. For the mixed dentition analysis, we calculate the space available and the space required. The space required, it's represent the mesiodistal width of the crown diameter of the anterior teeth, especially the mandibular incisors, and it's measured by use of the caliper or vernier or poly gauge, by the measuring the mesiodistal width of each tooth at the contact area, in addition to the estimated size of the unerupted permanent teeth, which include the permanent canine and the premolar first and second premolar. For measuring the estimated size of the unerupted permanent teeth or unerupted permanent canine and first and second premolar, we have three methods. The first method is the using of the radiograph. The second method is the predictable tables or the MOYER'S mixed dentition analysis, and the third method is the Tanaka and Johnston mixed dentition analysis. In case of the radiograph, using of the radiograph, we depend on a radiographic equation, and the radiographic equation is by dividing the unerupted tooth true width on the unerupted tooth radiographic width equal to the deciduous molar true width and deciduous molar radiographic width. For the deciduous molar true width can be measured from the study model or the study cast directly by using of vernier or caliper or divider, and the deciduous molar radiographic width is measured from the radiograph by using of divider, and the divider is transferred to the ruler to measuring the deciduous molar radiographic width or the deciduous molar width on radiograph. The unerupted permanent teeth width on the radiograph also measured from the radiograph, and when you have the value of the deciduous molar true width and the deciduous molar radiographic width in addition to the unerupted permanent teeth on radiograph width, you can calculate the unerupted tooth true width. After calculation, the unerupted tooth true width can be summation of the unerupted tooth true width of the canine first and second premolar, and the summation or the collective mesiodistal width of these unerupted teeth is multiplied for one quadrant, and by multiplying by 2 you can measuring the amount of the mesiodistal width of the unerupted teeth of 2 quadrant to measuring the predicted sum mesiodistal width of the permanent canine first and second premolar in 2 quadrant. Here, for example, of 2 quadrant in the mandibular arch, the required uh, space is about 43 millimeter, and the mesiodistal width of the central and lateral incisor in the mandibular arch is about 22 millimeter, and by adding the 22 millimeter to 43 millimeter we have a 65 is the amount of the space required in the mandibular arch. The same calculation for the maxillary arch is by measuring from the cast the mesiodistal width of the centrals and the laterals of the lower arch, which for example equal to 27 in addition to 44 millimeter of 2 quadrant of the predicted unerupted permanent canine first and second premolars, which equal to 71, and the 71 millimeter is represent the space required for the maxillary arch. By putting or calculating the space available in the mandibular arch with it's about 65.3, and the space required 65 as explained in the previous slide, and by comparing the two measurements we have about 0.3 millimeter positive, which represent there is a spacing in the mandibular arch. While in the maxillary arch, the space available is about 70.4 millimeter, and the space required is 71. That means when comparing the two space or the space available and the space required, that means is the result is minus 0.6 millimeter. That means there is a crowding in the maxillary arch and need a space which can be corrected by interproximal stripping in the maxillary arch to correct the mild crowding in the maxillary arch. The other method for calculating the predicted summation of the mesiodistal width of the permanent canine first and second premolar in each quadrant by depending on the predictable MOYER'S table. MOYER'S found in his research that there is a correlation between the collective mesiodistal width of the mandibular incisor with the predictable mesiodistal width of the permanent canine first and second premolar in each quadrant. And mostly we use the 75% probability level for predict the amount of the mesiodistal width of the permanent canines first and second premolar in each quadrant. For example, here in the mandibular arch, when you measuring the collective mesiodistal width of the mandibular central and lateral incisors and the collective mesiodistal width of the four mandibular incisor. For example, here you found it is 22 millimeter. The predicted amount of the mesiodistal width of the permanent canine first and second premolar in the mandibular arch with equivalent to 22 millimeter is about 21.4 at probability level of 75% for each quadrant. And in this case, by multiplying this value by 2 to find the predictable summation of the mesiodistal width of the permanent canine first and second premolar in two quadrant in the mandibular arch, we found 21.4 by 2 is equal to 42.8 for the mandibular arch. The same method for calculation the predictable mesiodistal width of the maxillary permanent canine first and second premolar by also measuring the mesiodistal width of the mandibular four central incisor, and when it is, for example, is 22 millimeter, the amount of the mesiodistal width of the maxillary unerupted permanent canine first and second premolar in each quadrant is about 22 millimeter. And by multiplying the 22 of the canine first and second premolar by 2, we will find 45 millimeter for two quadrant of the maxillary arch. The amount of 42.8 for the mandibular arch and 44 millimeter in the maxillary arch, it's represent the amount of the predicted mesiodistal width of the permanent canine first and second premolar in two quadrant in the upper and lower arch. The same number in the mandibular arch with the 22 millimeter, we have the 64.8 millimeter, which represent the space required in the mandibular arch, and by adding in the maxillary arch the 27 millimeter, which represent the collective mesiodistal width of the maxillary four incisors, and the 44, which represent the predicted summation of the unerupted canine first and second premolar in the mandibular arch. The summation of the two value is 71, which represent the space required in the maxillary arch. The 64.8 and 71 was put table of the space analysis, which the same 64.8 and 71, and compared with the space available, which is in the mandibular arch, for example, is 65.3, and in maxillary arch is about 70.4. In the mandibular arch, we found there is a spacing or positive 0.5, which represent a spacing in the mandibular arch, while in the maxillary arch there is a minus 0.6 millimeter, which represent a mild crowding in the maxillary arch. The third method is by using of Tanaka and Johnston mixed dentition analysis, or Tanaka and Johnston equation. The equation represents for the mandibular arch the mesiodistal width of the mandibular four incisor, or the central and lateral incisor, divided on 2 plus to 10.5, and in this case is equal to about 21.5. The 25.5 represent the predicted summation of the mesiodistal width of the mandibular canine first and second premolar in each quadrant. And by multiplying this number by 2, we will find 43, which represent the mesiodistal width of unerupted permanent canine first and second premolar in the mandibular arch. In the maxillary arch, we find the mesiodistal width of the unerupted permanent canine first and second premolar in each quadrant by this equation. The equation represents the mesiodistal width of the mandibular first, central and lateral incisor divided on 2 plus 11, which equal to 22, and the 22, which is represent the summation of the mesiodistal width of the permanent canine first and second premolar in one quadrant of the maxillary arch, and by multiplying it by 2, it's equal to 44, which represent the mesiodistal width of unerupted permanent canine first and second premolar in two quadrant of the maxillary arch. And this to the mesiodistal width of the mandibular central and lateral incisor, which equal to 65 millimeter, while in the maxillary arch, by adding the 27 to 44 millimeter, which equal to 71, and this represent the space required in the maxillary arch, and the 65 represent the space required in the mandibular arch. By the same of the other method, comparing the space available, adding to the space required or subtracting from the space required, we found 0.3 millimeter, which is represent spacing in the mandibular arch, while in the mandibular arch the result is minus 0.6 millimeter, which represent a mild crowding in the maxillary arch.